Hello. Today we're going to talk about topic 2, section 1, straight lines. So, hopefully you remember these equations. You've done them since algebra 1, okay? These equations will all be on your formula sheet. However, they're not going to be labeled, okay? They're all under one section just labeled equations of a line. So, you need to know the difference. Now, Cognigy calls them different. All right? The gradient is just a fancy word for slope. So that's the slope-intercept form, the general form, or what I called it in my class, standard form. And then the point gradient form is just a fancy way of saying point slope form. Okay, so these are your three equations. You want to know their names, all right, be able to recognize them. So first things first, let's start with, here we've got an equation. How do I know if a point is on that or not? Okay, yes, I could graph it and then just visually see, but there's an easier way. Okay, all the x's and y's here in this equation, the x and y represent a point on a line. Well, here you have a point. X comma y is your 3 comma 13. So if I make 13 y and then I change my x to a 3, I don't know what I'm writing there. Okay, let me fix that. Okay, I should get a true statement. Well, is 13 equal to 15 minus 2? Yes. So since that's true, that is on the line. Yes, that one's on the equation. Okay, so then we check B. So I'll make this my x and this my y. So is 3 equal to 5 times 5 minus 2? No, 3 does not equal, 23? So since that's not true, this one is not on the line. Okay, last one. Let's check C. Change the 0, make x 0 and y negative 2. So we get negative 2 is equal to 5 times 0 minus 2. And that is true. So we know that that point is on the equation, on the line. Okay? Example 2. Determine the y-intercept and calculate the x-intercept of the line. So here it's really important to know what an x and y-intercept are. So here's our graph. We know this is our y and this is our x. All right, the y-intercept is, think of it kind of as the, think of it as intersection, all right, on the y-axis. So you're going to be somewhere along here. Well, think about what all these points have in common, okay? This is 0, 1. This is 0, 2. This is 0, 3. Right? You're starting to see a pattern here that all of them have, sorry, had to finish it. So all of them have an x is 0. The y is what changes, okay? So it's all on that vertical line there, that axis. So the y-intercept is when x equals 0. So we plug that into our equation over here. We say y equals 2 times 0 minus 10. So we get y equals negative 10, right? We also could have known that by this being in slope-intercept form and this being the intercept. Okay, that's another way. This is the same thing. So our y-intercept, so if I ask you what the y-intercept is, it's a point. Okay, that's a C. All right, it's a point, so you're going to write it as 0, comma, negative 10. That's how you write your y-intercept. All right, for our x-intercept, all right, think about it. I'm going to be all the points here. Well, there's a relationship there. We've got going off my line here. We're going to have negative 2, 0, negative 1, 0. Here is 1, 0, 2, 0, 3, 0. All of those points are when y equals 0. So for our x-intercept, our y will always be 0. So we plug it in over here. We get 0 equals 2x minus 10. And then we just solve for x. So here, our x-intercept is going to be at 5, 0. Right, so those are our answers. Y-intercept, x-intercept. All right, the next example, it says a gradient, so a slope of 1/2, and it passes through this point. So put it in slope-intercept form. So I'm not going to start with slope-intercept form. I noticed we have a slope and a point, so I would rather plug it into point-slope form. So point-slope form is this. Okay, so here, let's see, we're going to get y minus 8 equals 1/2 x minus 4. So now all I need to do is put it in this form. So I'm going to get the y by itself. So I'm going to distribute that 1/2 and then move the 8 over. Ooh, not like that though. 1/2 x, and then plus 8, so what is that, plus 6? All right, so that's the equation of the line. Okay, of course that's not the only way. I mean, again, I have tutored a kid who hated point slope form, refused to use it, okay, unless she absolutely had to. So she liked it in this form. So this is an x, this is a y, and this is my slope. So plug in what you have. You have 8 equals 1/2 times 4 plus c. So 8 equals 2 plus c, so 6 equals c. So now we use this and our slope, and we write it in our equation, or in our form. Y equals 1/2 x plus 6. So see, there was 2 ways to go about this, and I'm sure there are countless more because every year I feel like there's a kid showing me a different way, okay? So just keep in mind that when you do a problem, it may not be the exact same way your friend is doing it, or I do it, but it doesn't mean you're wrong. So ask me what you did, and I'll help you, okay, and help you find your mistake, if you made one. All right, so example 4. So a line is passing through those 2 points. So we're going to write this equation in the form, or the equation of the line in slope-intercept form. Well, I've got 2 points, so I need to find the slope. So to find the slope, we can do y2 minus y1 over x2 minus x1. The biggest thing I want to say about this is I don't do the second point minus the first point. I keep it, I try to do it in my head, so I try to look at across. So what I mean by that is this point, these x and y have to come from the same point. And this x and this y have to come from the same point. So if I were to do negative 5 minus 13, so negative 5 minus that y, and then negative 2 minus 1, let's see, we're going to get negative 18 over negative 3, so we get 6. That's the same thing if I had gone the other direction. All right, doing what I know a lot of you want to do, 13 minus negative 5, and then 1 minus negative 2. So here we get 18 over 3, which is still 6. Okay, so again, 2 ways to go about the same problem. Okay, either way, you're going to get the same answer. So don't be alarmed if I do it first point minus the second point. Okay? So let's see. Now we've got the slope, right? So what we just found was the slope. And we have 2 points to choose from, so now we just need to make that equation. All right, I'm going to plug it into point slope form, and I'm going to use these because I'm going to avoid those negative signs because I know how some of my kiddos are. All right, so then we got 6 times x minus 1. All right, so y minus 13, 6x minus 6. We get 6x, what is that, plus 7? Perfect. Okay. Let's see, another example. All right, so a straight line, which always seemed very redundant to me because I would hope that all your lines are straight, but I digress. So here we have this equation. Rearrange it into ax plus by plus c. So that's standard form. Again, Cognity, it's international. They just do it a little differently. Instead of it equaling a letter, or I'm sorry, equaling a number, it's now going to equal 0. Okay. So again, a, b, c, if we don't remember, needs to be whole numbers. So we can't have that fraction. So if we've got this, I'm going to multiply each side by that denominator to make that, well, to make that denominator go away. So we get 3y equals 2x minus 21. And now I just move everything over. So I'm going to get, here it's probably easier just to move that 3y over. So 2x minus 3y minus 21. Now again, we should probably make sure it's in that perfect order, right? Because that's exactly the same thing. So 2x minus 3y minus 21 equals 0. I'll be honest, there is debate in the math community about whether or not a should be positive or negative. The old school way is that a should always be positive, and honestly, it's easier to read, in my opinion, because you don't forget it. Okay, so in my personal opinion, I don't think it really matters, but I think we're going to just stick to the general form. So for generalized testing, I would just play it safe and keep that a as positive, okay, because that's what I'm worried about. Okay, your test at the end of the year. All right, example 3. So a straight line passes through these points. Find the equation of the line in that form. Okay, so again, we can't just have x and y's. We need our slope. So I'm going to do 1 minus negative 4 and then negative 2 minus 3. So we get 5 over negative 5, so negative 1. I'm going to use one of these into my point slope form. And work it out. It's a positive there, but then times a negative. There you have it. Okay, so here we have the equation of, we're going to find the equation, a slope, a point, and give the equation in gradient point form. Okay? So this is just practicing going from one to the other. The most common equation you're ever going to use is point slope form, or gradient point form, because that's the most of the time you're going to be given enough information for that. So we're going to get y minus 8 equals 1/2 x minus 4, point slope form, or gradient point form. So then we want to transform it into gradient intercept form or slope intercept form. So distribute. Didn't we just do this? Oh, I don't know why I'm doing that. Okay. So equals 1/2 plus 6. And then we want to change it into standard form. This is slope-intercept, point slope, and standard form. So here I'm going to take that y equals 1/2 x plus 6. I don't like the denominator of 2, so I'm going to multiply everything by 2. So we get 2y equals x, or 1x, plus 12. So I'm going to move the 2y over and get x minus 2y plus 12. But then I'm going to put it in the correct format. And there you have it. Okay, so this trips up my students every year in Algebra 2. So maybe it's gotten to you now, I don't know, but it's parallel lines. We got to know that parallel lines mean the same slope. Okay, so if it passes, or if it's parallel to this, well, this is in the form y, well, standard form. Let's change it to slope-intercept. You get negative 2x plus 6. So here, the slope is negative 2. So if my equation is parallel to this, then that means my new equation, my new line, must have a slope of negative 2. It must be the same because it's parallel. Okay? And it passes through this point. So we can put it into point slope form. We get y plus 6 equals negative 2x plus 4. And there you have it. But it did say in general form. Ooh, I hope you didn't stop there. Okay, so in general form, we got to move that 2x over. Well, and the negative 2. So we're going to get 2x plus y plus 2 equals 0. I know, my instinct is always go slope-intercept. So make sure you read the directions. Okay, and before you type your answer, or before you write your answer, always reread the directions and make sure you're putting the correct thing, or you're putting what it's asking. Okay, so the equation of the line perpendicular to this, okay, well, if it's perpendicular, then it must be opposite reciprocals. So this equation is 2y equals negative 3x plus 1. I moved the 3x and the 1 over. Divide by 2. Now, my new equation is perpendicular. So my new slope is going to be opposite, so not negative, now it's positive. And instead of 3 over 2, it's going to be 2 over 3. All right, perpendicular is opposite reciprocals. Okay, so, all right, here, I'll write that. Now, it also passes through the point negative 2 comma 5. So, y minus 5 equals 2/3 x minus negative 2. And we're going to write the equation of the line. And here it didn't specify what equation, so you could probably just leave it like that. Yeah. I will, of course, be very specific on the test, so I will say which format, but if it just asks for you to write an equation, any equation will do. Point slope, slope-intercept, or standard. I'm sorry, cognitive terms. General form, what is it? Gradient intercept, and point gradient. It just sounds weird. All right, so now let's do number 3. Determine the equation of the line perpendicular to y equals 4. Okay, so here we have to remember what the equation of y equals 4 is. So if we think of y equals 0x plus 4, then that's some indication that our slope is 0. And I don't know what it is about this, but kids don't like to know, or don't like horizontal and vertical lines. So if we have a slope of 0, well, here's your options. You can either be horizontal or you can be vertical. Well, the other slope would have been undefined. This is horizontal. I can run horizontally. I can't run vertically. So the slope of a horizontal line is 0. The slope of a vertical line is undefined. Okay, I can run this way, so that makes sense to have a real answer for a slope. I can't run vertically, so I'm going to have an undefined slope. All right, there's an acronym that I learned forever ago called HOI-VUX. All right, so what that is it breaks it into your two types of equations. You have either horizontal and you have vertical. For horizontal lines, you're going to have a 0 slope. For vertical lines, you have an undefined slope. And for the equations, when you have y equals 0 slope, that is a horizontal line. When you have y equals a number, it's horizontal. So a vertical is going to be x equals a number. HOI-VUX. Okay, know that, love it. Okay, that's the difference between horizontal and vertical. So if I've got a horizontal line, okay, the perpendicular to a horizontal line would be a vertical. So I need the vertical line that passes through that point. A vertical line is x equals some number, and since it's going through this point, oh, look at that. It's going to have to go through x equals -1. The horizontal and vertical lines are perpendicular. So if I don't want the y equals 4, then I need the x equals, okay, or the opposite, the perpendicular. So next problem. Determine the equation of the line perpendicular to this and has the same x-intercept. Okay, so one thing at a time. Let's deal with it perpendicular to this. So let's find out what that slope is. And we divide by 4. So the slope of this line is -2/4, or -1/2. The perpendicular, so my new one, is going to be not negative, but positive 2/1. So my new slope is 2/1, and it's going to have the same x-intercept. Well, the x-intercept, if you remember, is when I solve for x and y is 0. So 3x plus 0 plus 2. We get, let's see, 3x equals -2, so -2/3. So I have the point -2/3, comma 0. Well, now I want to write my equation. So here's my point, here's my slope, plug it into point slope. Now since this one went away and it just became y equals, all right, I'm going to go ahead and distribute that too, and might as well put it in slope-intercept form, just because I think that would be easier to write, if for nothing else. So we get plus 4/3. There's my equation. Example 5. All right, so find the value of k if the lines are parallel and then perpendicular. So that's 2 questions. So let's start with the parallel. So if they're parallel, they're going to have the same slope. So let's put this as slope-intercept. So 4y negative 2x plus 1. Okay, and this one, I'll do the same thing. So let's see, I'm going to just move the 3y over. So kx plus 2 equals 3y. And I'm going to change that around. And then divide by 3. Okay, so now that I've separated the two equations and I've got them in slope-intercept form, now I can pay attention to their slopes. So this slope is going to be negative 1/2, and this slope is going to be k-thirds, or k over 3. So if they're parallel, that means negative 1 over 2 must equal k over m, or k over 3. So it's got an equal sign, so we can cross multiply. Negative 3 equals 2k. Negative 3 over 2 equals k. So that's the answer if they're parallel. Let's try perpendicular. Well, if they're perpendicular, that means their slopes must be opposite reciprocals. For them to be equal, I need to take the opposite reciprocal of this one. So it's positive, so make it negative. And instead of k over 3, we're going to make it 3 over k. Cross multiply, negative 1k equals negative 6. So k equals 6. So that's the answer if they're perpendicular. Okay. All right, so that wraps up all the examples on cognity. So this is everything that you should know by the end of the section. And there is one problem in the homework that I thought was a little bit upper level, and I think you're going to have some questions. So here's another example that might help you with those visuals. Okay, so here we've got a sketch of a roof, and we know the slope has to be 0.45, right? All roofs, all ramps, they all have to be at a certain slope. So we need to find out what should be the maximum height. Okay, so because we know how big we want the house. Okay, so here we know the span of S of the roof is 11 meters. So this is 11. Okay, which means this from here to here is going to be half of 11, right? Because these distances are going to be equal. All right, now you're probably thinking, okay, well, great, that doesn't really help me. It does, because think about what slope is. Slope is rise over run. And to go from here to here, I have to rise h amount, and I have to run 11 halves, or visually more appealing, 5.5. Okay, so our slope of this roof must be h over 5.5, but I also told you it has to be 0.45. So h over 5.5 must equal 0.5. So we multiply that out, and we should get 24.75. So let's see. What did I do? Did I multiply wrong? Yep, totally put the decimal in the wrong spot. Yep, smooth move, right? All right, so don't do what I did. Watch your decimal signs in your calculator. Okay, and that's all for 2.1.